Thank you for everyone for coming, and those of you who are online. I am going to tell you take you on a bit of a journey about the research that I've been doing since 2006 and where we started and where we're at today. So, here we go. Get this working. There we go. So again, I'd like to acknowledge the traditional owners of the lands in which we meet today. So of course, in the Turrbal and the Jagera peoples here in Brisbane City, but I also want to acknowledge the Quandamooka, the Cubby Cubby, and the Butchulla peoples, who are the traditional owners of which I work, and a lot of this research has actually been done. And I recognize that these lands and waters have always been special places of cultural, spiritual, and social and educational significance, and I thank them deeply for the care that they've taken of our shared land and sea country, and show my deepest respects to elders past, present, and emerging. So, as I said, I want to give you a little bit of background about the work that I've done. So I've been very fortunate. You can probably hear from my accent. I'm originally from Canada, but I've been very fortunate living in Australia since I was very young. I first came here when I was 17. Part of my journey was I got to work at Moreton Bay Research Station on North Stradbroke Island, or Minjarrabah. Several of you may know that. And while I was there, has anyone been to Moreton Bay Research Station on Straddie? Yeah, it's a big building in the middle of a neighborhood, right? And so what would happen is that members of the public and members of the community, if they saw sick or injured things, they would bring them to us. So I inadvertently became a turtle care person. Although my background was more in marine science around small fish like blennies and mud, all of a sudden I was thrown into the world of sea turtles. And unfortunately, we were always getting animals coming in, and it is a bit of a hot spot, Moreton Bay. There's about 200 strandings of sea turtles every single year. And we would get lots of animals that would be coming in that would be dying without any real obvious wounds. So they were skinny and weak, but there wasn't like a boat chop, and they weren't tangled in anything. So that really sort of got my science brain working. So I was like, why is this happening? What is going on here? And I started talking to other carers in other regions, and they were starting talking about the impacts of plastics, about turtles eating plastics. I then sort of asked around other turtle researchers, and I actually had a couple of turtle researchers say to me, oh, listen, don't worry about it. If they eat it, it's not a big deal. It just goes straight out anyways. It's not a problem. I can see a lot of you shaking your head. Like, now that's inconceivable to even think like that. But back then, and that wasn't that long ago, we're talking 2006, that was sort of the common understanding that wildlife ate plastic. It was fine. It's just going to pass through them anyway. At the time, the only data set that I had was the Queensland stranding database. And they had recorded about 2% of sea turtles having ingested marine debris or ingested plastic, and that possibly causing the cause of death. Now, 2% is really quite low and probably sustainable for a population overall, but it really did get me thinking about what was really going on here. What were we seeing with these sick and injured sea turtles? And we knew that while we only had 2% recorded on that stranding database, when I looked more globally, it was close to in a lot of other regions. So it made me think, well, are we special? Are we not getting these animals impacted, or is something happening that we're not really seeing? And so how are sea turtles impacted when they interact with plastics? In two ways. They either get entangled in it, so that's pretty obvious. You can see an animal tangled in a ghost net or in a fishing pot. Or the other way is, of course, ingestion. And that is the hidden killer. Because unlike this photograph, they don't actually swim around with a bag hanging out of their mouth. It's actually inside of them. So you can't see it. You actually have to open them up to have a look. So this is why I decided to really concentrate on ingestion, because it was the hidden killer. And nobody was really doing anything about it within Queensland at the time. So again, as I said, I'm going to take you on a journey. So this is, I'm a scientist. The very first question I had to ask was, well, is this actually a problem? If it turns out that it was only 2%, that's probably sustainable for the population overall when you think about things like other types of predation and things like that. So to do this, I started to get a hold of dead turtles that had washed up on the beach, or turtles that had gone to care and then subsequently died. And I did the very unpleasant job of opening them up and basically looking inside of what was going on. And it is not a nice job. It's very smelly, which is probably why nobody had really done it before I did. And we started to have a look, and we found out pretty quickly it is a problem. Over 30% of the sea turtles that we opened up had levels of marine debris that was indicated to be that its primary cause of death. We had other animals that also shut up with marine debris in their gut, but that we determined that wasn't the cause of death. But 30% at levels that was the primary cause of death for these animals. The next question I asked was, well, is it all species, or is it just greens? Because we see a lot of greens in the Moreton Bay area. It's the most common species. And unfortunately, it's every single species. And we had the very dubious honor of actually recording the very first flatback turtle who had died from ingested marine debris. So it's every species that is impacted by debris. Okay, so I said, is it a problem? Yes. Is it all species? Yes. Then I asked the question, does age make a difference? And it turns out that it does. So those of you who know a little bit about sea turtles, the sea turtles come up, lay the eggs in the sand. After a couple of months, the hatchlings emerge from the sand, and then they swim out and they do this big ocean basin drift during what's called the lost years. And during that lost years phase, they're basically feeding on the first 1.5 meters of the water column. So they're floating around and interacting with anything they happen to come along. Then they change their behavior and they start to come back in towards the coastal areas. And instead of feeding at the surface and feeding on floating vegetation, they'll start to duck dive down and feed on seagrass and algae and various other food. Now, the reason I told you about those lifestyles is that has been very much impact the way that they interact with debris. So the coastal ones, about 27% of the sea turtles are interacting and are being found with marine debris in their guts. However, those open ocean lost years turtles, pretty much even though it's as 55% there, I knew if I had a little dinner size plate one this size, I would be pretty much guaranteed to find it full of plastic inside of its gut. And that's because those animals are interacting with the stuff that's sort of floating on the surface. That then made me ask the next question. Okay, we know that the young ones are the ones that are interacting with the plastic, but are they just eating anything they happen to come across, or are they more selective? Now, I asked this question purposefully because I understand that polymers and plastics are part of our everyday life. There is no way that we're just going to disappear. So if we're going to be looking at, the impacts of plastics, we really have to be pragmatic and say, okay, well, if we're going to target something, what are the plastics that are the polymers that are making the biggest impact as far as the health of the sea turtles are concerned? And so that's why I went into this question about, are they being selective? Are they eating whatever they can come across, or are they targeting certain types of items? And it turned out the lost years, and that's an example of one of the lost years in the top corner sitting on that yellow mat, they are slightly less selective. They kind of, whatever they kind of interact with, they will consume. However, they are still picky. And just this picture that I've got up here, I can make this laser thing work. Does it work? No, it's not going to work. Oh, it did work. Here we go. Tape. Here we've got plastic bags. That's a balloon. That is the blue top of a water bottle cap, sort of broken down. Rope. This is the top of a thong, so a bit of a thong that's been ripped off. So it's sort of stuff from our day-to-day life that you're being found in the gut of these animals. Now that's the younger one. However, when you start looking at the older ones, they really have a preference, and the young ones still do too. soft plastic and balloons, number one things that they will target. I've actually been in the water and watched a turtle completely change direction because it's seen plastic bag in the water. Obviously, I've moved it out of its way so it doesn't eat it, but it will automatically go straight towards it. And it's also the seabirds. The seabirds are also attracted to balloons, but they also tend to be more attracted to hard plastics. This thing here is one of those Siloom sticks that a lot of the commercial operators use. And of course, that looks a lot like, you know, a bit of jellyfish or whatever the case may be. So soft plastics and hard plastics. So then the next question was, well, why are they eating it? Come on, it's not good for them. What's the point? Why are they eating the things that they're eating? And it's because they're being tricked. It's because they visually look a lot like their native things that they would be consuming. So in the case of the sea turtles, the polymers in the plastic bags look visually a lot like a jellyfish. And I know that all species of sea turtles, jellyfish are the one thing that they all eat. And they will stop what they're doing to go eat jellyfish if they see them, including the turtles, which are thought to be more herbivores. The other thing, of course, is that, like, as I said, the birds, they have a tendency to eat a lot of balloons. And one of the things that they love are the red arrow squids. And again, a red or a colored balloon in the water looks a lot like their native food source. We also went ahead and actually did a little bit more investigating into the vision of sea turtles and found out that not only is the visual, physical thing of a bag looking like a jellyfish, it's also getting tricked by an additional visual cue. We know that jellyfish, we also found out that plastic bags polarize light. The next question was, do sea turtles see polarized light? And we found out, yes, they do. It looks like it's one of the things that they use to be able to navigate those big ocean basins. So the turtles are being tricked two ways. It looks kind of moving and kind of sitting mid-water like a jellyfish would, but then it's also giving an additional visual cue to say, no, you should eat me. This is the thing that I should be, this is something that I should eat. The other thing is their behavior. Yes, here we go. So this, I've put a GoPro camera down at one of the cleaning stations at Lady Elliot, and this is a sea turtle that's come to investigate it. I don't know if anyone's seen a GoPro. It's in like sort of a transparent case. These are like dogs. The way that they interact with their environment is through their mouth. So if they find something novel or interesting in their environment, even if they don't necessarily want to eat it, they will actually well. So there's a behavioral component to that as well. The next question is what happens when they eat it? And so this is me, and this is a sea turtle that we had brought into the Moreton Bay Research Station that ended up being full of plastic. It's still alive at this stage. So the next question we asked was, okay, we're seeing animals feeding on plastics, and we asked the questions, how many pieces of plastic does it take to kill a sea turtle? Thinking, well, let's at least get some sort of concept of what's happening out there. And so we went out and we necropsied almost 250 turtles. We had an additional 706 records from the stranding database. And the answer was quite shocking. It turns out that it only takes about 14 pieces of plastic to kill about half of the population. So those of you who may or may not be familiar with the term LD50, that's a lethal dose 50. You would normally use this for testing the toxicity of a poison. We did a similar sort of thing, but instead of normally LD50 experiments, you feed your test subjects various concentrations of the toxin to be able to determine, what's the lethal dose that kills 50% of your population. That is hugely unethical to be doing with an endangered sea turtle. So we actually back calculated it. So we found out how many turtles had died from that, and then did this back calculation to determine that an LD50 of 14 pieces of plastic. Shockingly, though, there's still a 22% chance of a turtle dying if it even just consumes one piece. So that was really concerning as well. And of course, as you can imagine, like this. Oh, that's that little flatback I was talking to you about, our very famous flatback, the first one to show that it had, died from marine debris ingestion. You can see all the debris that's in that animal. If we hadn't recovered that animal and done the necropsy and removed that debris, that animal would, the environment, the animal itself would have decomposed, but all of those plastic pieces would have been released back out into the environment again. So it's a continuing cycle. I was often asked this question, particularly in the very beginning. So as I said, I've been doing this since 2006. In the very early days, people would always ask me, has it got worse? And I'm like, well, I don't know. We've only been looking at it for a couple of years. We're not quite sure. But we ended up doing a metadata analysis and went back through time. And actually, we were able to get information all the way back to the 1800s, late 1800s. And unfortunately, the problem has definitely got worse. The likelihood that a green sea turtle, for example, has eaten marine debris has doubled since just even 1985. And we estimate 50% of the world's sea turtle population is swimming around right now with debris in their gut. Well, microplastics, so this is macroplastics, stuff that you can easily see with your eye. Microplastics, pretty much every study that's been done on sea turtles looking for microplastics, everyone has it. So they've all been exposed to microplastics as well. So that's pretty depressing. Okay, now we're asking the question, where are they getting it from? Because when I started to release this and have these kind of conversations, I'd often have people come up to me going, oh, well, it's not our fault. It's because of Indonesia, and it's because of, Papua New Guinea, and it's all these people who are making plastics. Like, okay, well, let's answer that question. Where are these animals interacting with plastic? Where is it potentially coming from? Well, it turned out it's locally. Basically within 250 Ks of where we found the animals stranded, and we did this by using modeling. Those of you might know about the oil spill modeling that CSIRO uses, the Kerry program, where they can actually do drift models to see, okay, here's a oil spill shown up on a shore. Where did that originate from? We use that same technology, but saying, okay, here's where a turtle washed up. This is the date. These are the geographical locations. And we backtracked as to where that animal potentially interacted with the debris. And again, as I said, it's pretty close. 250 Ks, that's definitely within Australia's coastline, right? That is our backyard. 80% of that marine debris, of course, is land-based as well. So it does mean that the other 20% is coming from things like fishing sources and boat sources. And as far as fishing and boat sources are concerned, it really is those, the highest impact is really around entanglement. So things like your fishing line and just, this is my home on Stratty. This happens every once in a while when we get a westerly that comes in, and all of this rubbish just washes in from the ocean and ends up collecting in these quite isolated areas, which just does not have the normal population. It just washes up. So again, just some examples of impacts of lost fishing gear. So you've got those ghost nets and the crab pots. Instances, the fishing gear doesn't know that it's lost. It'll continue doing the job that it was designed for. And so unfortunately, sea turtles and other animals end up getting entangled in it. But it's not just, fishing gear is not just an impact externally. We also have impacts internally. So in this particular photograph, this is a green sea turtle that we brought in. You can see first of all, how much plastic is in this poor animal's gut. And all those little bits of fiber, those are little bits of fiber that comes from fishing ropes. And there's also fishing line and various things in there as well. But a lot of plastic bags, a lot of plastic bags. Most, almost 80% of what we found in that animal's gut is basically those film-like plastic bags sections. Okay, so that was working quite locally. Now we started to think globally, and we wanted to ask the question, what are the risks to sea turtles, to marine debris, like interacting with them? And so the first thing, and we didn't do this, this was work that was done overseas, is they did some modeling to look at where the debris collects. Now, have some of you heard of the Pacific Rubbish Patch? Yeah, so that's probably the most famous one, and that's this area here. Let's see if I can make this work without making, here we go. That's this area here. The Pacific rubbish patch is the most famous of all the rubbish patches, but I want you to have a look. Pretty much every ocean in the world has a rubbish patch. It just happens to be the Pacific rubbish patch is the most famous of them all. And it's because that floating debris is being collected in these eddies that naturally form within the ocean basins. So that's where the debris is. But then we wanted to say, well, how does that interact where the turtles potentially are? And so we ended up creating a risk map, a global risk map looking at where are there places in the world where we should really be concerned about sea turtles and them interacting with marine debris. I just want to go back one slide a bit. Now, just look on the east coast of Australia here, and even the west coast of Australia. You know, from a global perspective, we haven't really got a lot of debris, which is good news. That's really fantastic. However, as soon as we start to overlay where the sea turtles are, that changes. And that's because we actually have a lot of sea turtles hanging out very close to shore. And so even though the level of debris isn't as high, the probability of them interacting with the debris because of the numbers of sea turtles that we have has actually increased. So this risk map has been really useful because a lot of people around the world have been able to use that, like in Hawaii, off the coast of Africa, to start coming up with mitigation plans to try to reduce the impacts that the sea turtles are having as far as marine debris is concerned. So let's concentrate a little bit back to Australia now. And this is the most recent paper that we did. You guys are geographers, so you know this. It's actually easier to do things on a global scale when you're working with sort of bigger data sets that have less smaller definition. When you start to get smaller and you start to be looking at things like at the Australian level, and then even farther still looking at things like the coastal line, it becomes more complicated for modeling. So anyway, so the first thing we wanted to do is we asked about what are the debris hotspots in Australia. So building on what we had done in that larger global model. And not surprisingly, basically all down the east coast of Australia, around Perth, up at Coral Bay, and a few hotspots around Darwin. These are really where we're getting a lot of debris collecting along in our coastlines. And it's not necessarily related 100% to population levels. There is an association with mangroves and there's an association with ports, but it's also really related to currents and where sources and sinks of where things end up going. So we did a similar sort of thing. So that's this case, we were trying to figure out where the debris is. And we did a similar sort of thing looking at high risk areas of looking at endangered animals around Australia. Where are some places that we should really be concerned about? So we looked at green sea turtle distribution. So that first one here, this is the map of where you can find green sea turtles around Australia. And then this is our risk map. And there's high risk areas consist of about 2.2% of their distribution. So that's actually kind of good news. It's not like everywhere that they're living that they're having a high risk of interacting with debris, but there is some very defined hotspots. And quite surprisingly, dugong had even a higher level of risk. So they have about 5% of their distribution is areas where they're going to be interacting with marine debris. And this is often because they're in those really shallow bay-like areas, which of course is where debris often ends up collecting as well. Okay, so as I said, we've gone global, come down to Australia. Now I want to really concentrate in on Southeast Queensland. And so that was the next area we started to look at. And we did debris distribution in Southeast Queensland, 45 sites along the coast from Bundaberg down to Jacobs Well. And we were looking for things like plastic bottles, reusable bags, plastic bags, and then also total debris. And the reason we had chose those ones is because in 2018, we had both the container deposit scheme and the plastic bag ban that came in Queensland. And so we really wanted to see, is there any differences between what we see now and then? We continued on doing the necropsies. So we did over 350 sea turtles looking for both those micro and macro plastics. So building on the work we had done previously. And as I said, we divided into pre-2018, which was before the legislation had hit, and then compared it to post-2018. So we waited a couple of years until 2020 to start doing this comparison to see what was going on. So first of all, the debris surveys. What were some of the results of that? Yeah, I know. Well, it's a good news, bad news story. Morton Bay, unfortunately, had the highest amount of debris across all the three regions. So we compared Hervey Bay, the Sunshine Coast, and Morton Bay. So those are the three broad regions that we compared. And Morton Bay had the highest amount of debris across those three regions. Unfortunately, there was no significant change between 2018 and then post 2020 onwards in the amount of single-use plastic bags or containers at that stage. And unfortunately, there was now a new type of debris that showed up as well, which was the reusable bags and COVID, which we hadn't, COVID-based items. So things like this seagull playing with a face mask. And we actually wrote an article about this, not just being affected here in Australia, but also lots of other places around the world where COVID-based debris impacted animals because it was just getting washed out. So much so, we actually found a piece of a face mask in the gut of one of our sea turtles that we had necropsied as well. So yeah. Anyway, however, so that's the bad news. However, there was a significant decrease in total debris overall. So even though some of those target items hadn't really changed in over time, the overall amount of debris had significantly changed. And we really think that was because of increased community awareness, because by that stage, the plastic bag ban, people were talking about things like the straw bans. And so there was more of an engagement from the local community and changes in behavior. Okay, now looking at the debris ingestion. So have things changed? So as I said, been doing this since 2006. This is just data up until last year. Unfortunately, there's not really been a significant change in the percentage of turtles that are still ingesting marine debris. So it's still around 25% for these coastal ones. Over 50% is still soft plastics, like your plastic bags. You know, that strip in the center is the last little bit of your cling wrap roll that gets left behind. That's what that is. And unfortunately, it's one of those things until these articles are removed from the environment, because these plastic bags are not going to break down. They get smaller, but they're not going to decompose in any way. So until they're removed from the environment, unfortunately, there's still a risk. But there's been some legislative efforts, because I don't want you guys to feel depressed. I'm going to talk about that at the end, because there has been some positive change in that space. And I'll talk a little bit about that at the end. Now, changing and shifting a little bit. In 2018, I took up my position up in Hervey Bay through the University of the Sunshine Coast, and we were heavily hit soon after that. Well, obviously we had COVID, but then soon after that is when all the flooding started. And we had very major impacts. So since January 2022, the Fraser Coast region was impacted with 4 major flood events. They reached levels of up to 10.7 meters, which was close to the 2013 levels. And consequent is because we had so much of that highly turbid water moving into the bay itself, we had a mass smothering of seagrass. Some of the seagrass beds had as much as 1 meter of fine silt sitting over top of them. So they just didn't survive during that time period, to the point where there's now less than 1% of, it's starting to recover now, just this year, but where it was less than 1% of the seagrass beds being alive and available in Hervey Bay. This is not great news, because we have around at least 1,000 dugong that live up in that area, and around 50,000 sea turtles that live in that region. So that's not a great news for the animals that are living there. And so what ended up happening? First of all, we had an increased number of strandings, and stranding means a sick and injured turtle sort of showing up on or washing up onto some of these shore areas. Unfortunately, we had over 10 times more than 2019. I'm going to show you one of my few graphs during this on the next slide. And unfortunately, it just continued to get worse after the flooding stopped, because even though the flooding stopped, that seagrass hadn't come back yet, right? So as we went along further in time, the animals had less and less, they weren't getting their food resources, and so animals were still stranding and continued to get worse. This put a huge amount of pressure, particularly on the rescue groups that work up in that area, who are all volunteers. And it really did stretch rehabilitation centers. So animals were getting sick. They'd be traveled down the highway to places like Australia Zoo Wildlife Hospital, to SeaWorld, to Sea Life for rehabilitation, but they were bursting at the seams. They were having to make really hard decisions about which animals they keep, which ones couldn't potentially be saved. It was a really difficult time. This is just a graph to show you how insane after the floods, we had the number of strandings that occurred. So this is the sea turtles admitted to Australia Zoo Wildlife Hospital from Hervey Bay, starting back in 2010. And you can see the floods started happening in 2021, and it just continued on growing, and even up to 2023. It's now starting to drop again because the seagrass is coming back, but just continued on growing over time. And this is 10 times the amount of what the rescue groups were having to deal with up in this region. So what are the reasons they were going into care? Why are they going into care? Well, obviously, first one is starvation, but they were still having things like getting entangled and things like fishing gear. Do you guys remember the floods? Like, there was so much debris that came down the rivers, right? Even on the backside, on the eastern side of Gari, there was one of the barges or one of the platoons from the Brisbane River got washed up on the back of there. So all this stuff was washing into the bay and into the region. But marine debris and ingestion and entanglement was still an issue. Fishing gear ingestion, boat strike, parasite overloads, which are things like this this thing here, which is a papilloma, which causes this sort of like cauliflower type tumor-like growth. And finally, we started to get a new disease, which we had never seen before, but appears to be associated with what is happening with the actual flooding events, and of course starvation. But I want to talk a little bit about that disease I was just talking about. It's this new disease, which fortunately hasn't been seen in Moreton Bay yet. It's called the soft shell syndrome. And what ends up happening is the shell of the turtle itself becomes so soft, and the animals are really lethargic and very flat. The first time people saw them, they actually thought the animals were dead, because it looked like they were decomposing, because the shells were starting to break down so much. And it peels, the shell starts to peel off. I've had the opportunity to open up a few that didn't survive, and the soft shell is just a symptom of what's going on internally. Basically, it's massive organ failure. The heart, the kidney, the liver, everything is just breaking down. And so we're not quite sure what's causing this. There's a big team of us that are working on it at the moment to try to figure out what's going on. And best news, it's at least still contained in Hervey Bay, and it hasn't moved into the Moreton Bay region yet. So just a little bit more about turtle strand Southeast Queensland. I did tell you before that we've got an estimated about 20,000 sea turtles down here in Moreton Bay, with about 50 up in Hervey Bay. Unfortunately, both of these bays are identified as major hotspots for stranding sea turtles in Queensland. And while the turtles from Moreton Bay, as I talked about before, do have access to those facilities in a pretty fast manner, those poor ones coming down from Hervey Bay are having to do a road trip to be able to get access to care. And despite the need, there's currently no rehab facilities between Gladstone, that's the closest one north, and then the Sunshine Coast, which is the closest one south. So a 3-hour drive to the nearest facility. So this is where I came in. I said, well, what can I do about this? And I had a vision, and I started reaching out to the local community, worked really closely, not only with the Turtles in Trouble Rescue Group, who were the group that were having to deal with all these sick and injured animals, but also the Butchalo, who are the traditional owners up in that region as well. And the three of us came up with a plan. And the plan is to create a sea turtle, or what we call the Milby Center, Rehabilitation Research Center based up in Hervey Bay itself. It's going to be a combination of animal care, but it will also have the additional bonus of being able to research into their causes, because most rehabilitation centers spend most of their time just caring for the animal, cleaning tanks. They haven't got time to try to figure out why they're seeing what they're seeing. So the idea is that with my group, we'll be able to actually start to research some of those causes and try to come up with for why it is the way it is. As I said, it's a fantastic collaboration. It's a wonderful collaboration between the traditional owners, which are Buntak, the uni itself, the Turtles in Trouble Rescue, Queensland government, federal government, state, the local council, Australia Zoo Wildlife Hospital, SeaWorld, as well as a range of industry partners. And so we've been fortunate enough to raise 1.8 million to be able to create this center. And you guys are revealing, this is what it's going to look like. So this is the UniSC Milby Sea Turtle Rehabilitation Center, or the Milby Center for short. This is just an artist mock-up at the minute, but this is what we're hoping to be able to open in 2025, which will help solve some of these issues that we're seeing up in the Hervey Bay region. So, as I said, here's our positive vision for the future. So this is what we're hoping to be able to help some of the turtles in that region with. Now I want to just reflect a little bit on the past. Sorry, I've given you some positive. Now I'm bringing you back down again. This is looking at the amount of plastic that's been entering the oceans since back in 1950. And when I started this research, there was about 9 million metric tons of plastics being estimated to be going into the actual oceans or being in the oceans each year. We're now up to 278 million tons in the time. So this is when I started my research. This little blip is when the Japanese tsunami happened in 2011. Those of you might remember that. And we're now, it's still happening. It's still going up. It's not plateauing in any way, shape, or form at this moment. So it's a 30% increase in the amount of plastics in the ocean since I started this research. Again, as I said, in the early days, like when I tell people that in the early days, I was sort of poo-pooed by the scientists at the time going, well, why are you even looking at this? It's not a big deal. Like, that's unconceivable now. Like, we know that this is now a big global issue. But as I said, it's not all bad news. There has been some really seriously positive legislative change. If you had told me back in 2006, when I had first started this project, that by 2018, that there would have been a plastic bag ban in Queensland and a container deposit scheme in Queensland, I would have laughed at you. I would have said, no way. There's no way we can get legislative change happening that quickly. And it did. But it's not just here in Australia. Internationally, they're currently negotiating the Global Plastic Treaty. So the UN Environmental Assembly, there's 175 nations who have voted together to do something about plastic debris globally. And it's hoping to be implemented in 2025. And the big ones, the three priority things that they're working on are single-use plastics, fishing gear, and microplastics. Those are the three things they're trying to target from a global perspective. So that's really good news. At a national level, we now have the Australian National Packaging Target set to go to phase out problematic single plastics, but again, by 2025. And we have a national plastic plan with the Commonwealth government has committed to phasing out loose fill polystyrene, because polystyrene is another big problematic one. This is a scorecard, which I'll talk about in a second, because at the state level, 7 out of the 8 Australian states and territories have actually committed to banning single-use plastics, which is fantastic. And lightweight plastic bags, these carry bags, which you saw from all of our photos, that tends to be the stuff that the turtles are targeting the most, is across the board. Every single state has now actually banned those. It took Western Australia and Tassie a little while to get there, but they got there in the end. And as you can see from this chart, it's progressing. You know, we've really made some serious progression since I started doing my research. And the fact that this legislative change is happening, not just at the state level, but also at the international level, is really where we need to be working. So we still have a way to go, but I really feel that we're on the right path. So just some take-home messages. Plastic polymers are useful. We're not going to get rid of them anytime soon. You know, the medical industry, I think, would completely collapse if we didn't have polymers, for example. So they're going to be around, but we need to be a little bit smarter about them because there is some really serious long-term consequences to their usage. And we do know that single-use items, and it's domestic items. I guess that's the other thing I didn't highlight from those photos that you saw. You probably recognize the stuff in there. It's not like it's coming from a factory. Well, it is because it's made in a factory, but it's our everyday consumer-based products. So it means that it's all of us that are having to deal with this issue. And it's the single-use items that are the biggest problem. But to solve this, in the early days, I used to talk a lot about let's recycle, let's make sure we have our sink, which I still think is important. We need to have our reusable. But has anyone tried to be plastic free? Has anyone even attempted? They used to have like a plastic free July. It's virtually impossible. And that's not our fault. It's because of the manufacturing and the legislation that's available at the moment as what is being provided to us. So to really deal with this problem, yes, as an individual, you can take small steps, but for us to turn off that flood of plastics that are continuously going into the ocean, we need to turn off the tap. We need to look at these legislative and the manufacturing side of these, particularly the single-use plastic. So we need to look at legislation, we need to reduce production, we need to reduce consumption, and reduce disposal rates, and start to work into that circular economy, which again, at the UN level, that's what they're really talking about, is looking at that circular economy, that anything that's produced needs to be taken responsibility for by the manufacturers, and it gets recycled and reused back in a circular fashion. So that's it. Thank you, everyone. That's a little QR code if anyone wants to know a little bit more about the Rehabilitation Center. As I said, that's kind of our big, nice, bright ray of sunshine. At least we've got something that's happening up there to help the sea turtles in that region. And we're hoping to open in 2025. So thank you very much.
Thank you, Kathy. A thoroughly fascinating presentation. For those that have been here before, we now dive into some questions from the floor and those online. Does anyone have a question they'd like to open with? Up the back.
I'm Deanna Oxenford. I'm a Groggy Island field worker.
Oh, fantastic.
And
thank you for everything you do.
Pleasure. It's, yeah, when you're hooked on turtles, right?
Yeah.
I've documented over 400 strandings since I started in the Plumstone and our circular area. Yeah. With the floating syndrome with the bums up, is that always plastic ingestion? No. So there's also they can get a parasite infection, which is from a spororchid blood fluke. Right. And externally it presents in the same way because this spororchid blood fluke basically causes gut necrosis as well. So the same outward symptoms are the same, but it's not just plastics. And can you tell if they're plastic strandings without doing a necropsy from the stranding documents that we send in?
No, not unless the only time we can tell that is when things have been opened up, or alternatively, sometimes they go into care and then they'll start to defecate out plastic or fishing line. So obviously we can tell that way. But the only way you can 100% tell is when we've done a necropsy if the animal has passed away.
Can I just make one more comment?
Of course you can.
I recently had a lovely big female green wash up dead, but she was a bilateral upper lipper amputee. Yeah. And she had a gut full of grass that we found when we started pulling out the fishing line. Yeah. So, I can't understand how without her front flippers, she was able to make it to the seagrass beds to ingest the seagrass and obviously the fishing line that was in the seagrass as well.
Yeah. Yeah, they're amazing. Sea
Yeah.
turtles are
So
just,
she probably found some shallow seagrass.
yeah, well, I mean, so both of her front flippers were
Yeah,
gone.
right up to-
Wow, that's incredible.
I'll show you the photos.
Yeah, I mean, but they are very resilient
It was
creatures.
just so sad.
Yeah,
You know, we see so much sadness.
yeah, I completely agree. They also have the ability to move their back flippers, so
Yeah.
undoubtedly that's what she's using. Like she's using them. But yeah, no,
We had
tragic.
3 loggerhead strandings this year. We haven't had that before.
yeah. I think because they're moving down from Hervey Bay, because there hasn't been a lot of food up there, so they're,
This is during the nesting.
yeah, yeah. Thank you for that. Any other, do you have a question?
Question, Ian?
Yes,
Yeah, Christopher, I'm a plastic consumer.
yes,
Thanks for not demonizing it.
of course
We do
not.
need it.
Yeah,
How does the plastic domestic waste, which I saw the refuse truck take away from my house today, how is that getting into the sea? Is it general litter that gets washed through in the stormwater system?
Yeah.
Is it willful beach bad behavior, or what is it?
kind of all, the answer is yes. It's kind of all of those things, but a lot of material does actually escape from landfill, particularly the soft film-like plastics, 'cause it just takes a wind, right? And they can blow it and it can disappear from the out of the actual, even if you've done the right thing, it can sometimes still make its way into the sea. And the problem with the sea is it's literally downhill from everywhere, right? Like it's, if it starts somewhere and it doesn't get disposed of correctly, eventually it's going to make its way down to the sea. And it's also back just down to sheer volume of the amount of plastics that are in our everyday life. And again, this is why I've changed this conversation, because I think for a really long time, it's been about, oh, it's you consumers. You're doing all these things, you're buying this stuff and you're releasing it. But if you have no choice, what can you do, right? Like, and that's where we're at. Like, it's very difficult to not be exposed or somehow have to deal with plastics in our life or polymers in our life. So it really is at that taking those manufacturer levels approaches of, okay, how can we solve this issue? And I was very fortunate to be on the roundtable when they were talking about the plastic bag ban in Queensland. And of course, we had the big grocery companies at the table. And they said, listen, from an economic perspective, it would be great if we didn't have to give out plastic bags, because it costs us X, thousands or millions of dollars a year to be able to buy these and provide them to our customers. But we are not going to be the ones that are stopping providing these plastic bags, because we will lose market share. If we're going to do this, it has to be for everybody. It needs to be a ban from basically from the government. The government has to be the bad guy that has to come in and say, nope, we can't have this anymore. So there's a lot of goodwill out there, but you have to kind of manipulate the system, so to speak, to be able to actually see some of these bigger changes happening. Yeah.
Right. And it was just like the soy sauce fish.
Yeah.
Which are, these things, they're peripheral ephemeral to our lives, but they can kill a sea turtle.
Oh, 100%. One of those little soy sauce fish, I mean, there's not only the sea turtles are going to be going after that, there's the birds and everything else, because it looks like a fish, right? So, yeah. Yep.
Kathy, is there a viable soft plastic recycling business in Australia these days?
That's been part of the problem as well. Like, for a really long time, we were sending all of our recyclables offshore. They were going to China and various other developing nations. Unfortunately, what ended up happening, of course, is that they just got inundated and they said, well, whoa, stop, we're not taking any more. And Australia was left on the back foot because we had not invested in recycling areas in Australia itself. It was all being sent offshore. So that's now changed. There's now been a lot of investment in recycling plants in Australia. So, it's not just being stockpiled somewhere. It's actually happening. But the soft plastics are still problematic. It's one of those polymers that are very difficult to recycle.
Does any still go offshore, or is that stopped completely?
It had, yeah, it got stopped completely. Again, that was like an international policy thing because they realized that developed nations were dumping all of their junk onto developing nations. So, which is not very ethical in the long term. We need to deal with our own waste, right? Yep.
Well, it's good that all the states are coming in on about stopping the, or reusing plastic, because here in Queensland, in our turtle territory, we're at the end of the East Australian coastal current. We're getting everything from
Yes.
way down.
Yeah.
And for instance, I've been cleaning the beach on Moreton for almost decades.
Yeah.
And you get plastic bags and balloons emblazoned with Gold Coast political messages.
Yeah.
And stuff but it comes from further south.
Yeah. But they'll also be getting stuff from their further south too, right? It's just all conveyor belting. Yeah, it's longshore drift. Geologists, it's longshore drift. But the plastic is doing the same thing, right? It's moving up the
I was
coastline.
also involved in Seagrass Watch
Yeah.
out on Moreton Island too. And one of the lovely things is to see a dugong trapped in
Yes.
seagrass.
Yeah. They're pretty
So
special.
really
No, that's fantastic.
We have some questions online, then we'll come back to in the room. First one was, is soft shell syndrome comparable to the skin diseases observed in Gladstone Harbour after LNG associated dredging?
No, so it's something very different from that. I mean, superficially, it obviously causes lesions on the skin and definitely causes the scutes to start to peel off. There's actually hemorrhaging underneath the scutes itself. So it's something different than what we were seeing in the Gladstone Harbour region.
Is there any comparable diseases anywhere else in the world?
So I have had an opportunity to talk to my international colleagues, but keep this in this room because it's still a hypothesis at the moment. But a colleague of mine who was working in Dubai and was running a turtle rehabilitation center over there, they had an outbreak of foot and mouth disease in Dubai, and it turned out that may have been linked to that in Dubai. I don't think it's here because we don't really have foot and mouth, and gosh, I hope not, because that would be terrible for Australian industries. But yeah, that's just one of many hypotheses that we're currently chasing at the moment. We don't really know, is it viral? Is it bacterial? Does it have to do with their diet? Because we know that the sea turtles, because they weren't eat seagrass anymore, were moving up into the mangroves, and they started to feed on the mangrove leaves and the mangrove saplings. And a lot of those mangroves are quite toxic. They have toxins in their tissue, plus they're really heavily loaded with salts too. So if these animals are forced to change their diet in that way, that might have something that's contributing to it as well. So we're still, as I said, there's a big team of us. Each of us have a little piece of the puzzle that we're trying to put, and eventually we're trying to put it all together to try to figure out what's going on.
Interesting. We had other questions of, are the seagrasses in Hervey Bay returning?
Yes, the seagrasses in Hervey Bay are thankfully starting to return, which is really good news. So hopefully we don't have another, because they feel like they're starting to recover now.
And then from that, do biodegradable plastics have a positive effect?
Biodegradable plastics are a double-edged sword at the moment because it still makes people rely upon plastics. But the good news is that if we can start using biodegradable stuff, particularly for some of those single-use items, it means that we're cutting off that source, right? So there is definitely some positive effects around biodegradable. Doesn't necessarily have to be a polymer. It could be made out of things like cornstarch or other types of materials that are more biodegradable. So that's literally the big thing that's happening right now, particularly in materials engineers, is they're trying to crack it. How can we come up with a stable biodegradable polymer that can be utilized for packaging? Because I had the opportunity to get, because when I was working at the research station, we had a bit of a go on the island to try to convert all of the shops, and we got a grant to be able to have all the shops to have biodegradable bags instead. So there was still a polymer made out of cornstarch, but they didn't have a shelf life. Like they would literally start to fall apart on the shelf. So they were very good at what they were supposed to do, which is to grade. But from a business perspective, that's not great, right? Because if you're trying to give out a bag and it literally falls out the bottom. So as I said, as far as material engineer is happening, this is the hot topic right now. Material engineers are trying to figure out how they can make a stable biodegradable material. Yeah.
Are they looking at blister packs that are used for pills?
Yeah,
Think
that's,
about the oil and hard plastic.
yeah, I know. Well, see, I mean, as soon as you start going down that rabbit hole, you realize how much is around us. So as I said, that's the hot topic right now. How do they come up to replace all of these things that are literally in our day-to-day life to something that is, you know, biodegradable, yet is still stable and is still, you know, doing the job that it's supposed to be doing.
More questions in the room?
Are endoscopies used to retrieve some plastic and bottles that?
Yeah, so it depends. So we have had opportunity, we've had various success in animals that have had gut impaction. So often it's a case of big dose of antibiotics and then basically a type of laxative to try to move stuff through. If it's something singular, like say a fish hook, because they can often, you know, they can see that in the X-ray, then they will use laparoscopy to try to get the fish hook out. But as far as gut impaction is concerned, it depends upon how far gone that animal is, because again, I see them post, and in some instances, their gut, there's really nothing left. Like it's just hollow tube. There's no gut lining left. It's not doing the job it needs to do. So even if you pulled the stuff out, the gut is not functioning anymore. So yeah, it's not great news, unfortunately. David Author asked the question, sending plastic offshore means burning more fuel oil to power the ships. Exactly. It's a catch-22 situation, right? We really need to be dealing with it on our own shores as well.
Neil?
Two questions about sedimentation.
Yep.
Is there any evidence to indicate that it's riparian management that's causing this, or is it a natural phenomenon?
No, well, I mean, so both Hervey Bay and Moreton Bay are used to floods. So that's kind of, it's a boom and bust cycle going back in time. So and a lot of the corals and a lot of the seagrasses are actually relatively tolerant to relatively extreme floods, but they tend to be spaced out a bit. And for seagrasses, ironically, normally a flood is pretty good. Like it's negative initially because it will, you know, reduce the water quality so that it can't photosynthesize as well. But once the water quality starts to clear up, it's like it's been given a big dose of fertilizer. It is a plant after all. And so in normal situations, as long as the brood stock is there, for lack of a better word, it will actually recover pretty well. And both Hervey Bay and Moreton Bay, being coastal bay and catchments, are used to this boom and bust cycle. The problem is like what we had in 2020, 2021, 2022, where we had back-to-back years of flooding, and the seagrass doesn't have an opportunity to recover. That's when it becomes a much more of a problem, and the sheer volume of sediment that was coming down. As I said, some of our sites, there's 1.5 meters of fine sediment over top of what used to be the seagrass bed. So, and of course, land management, riparian vegetation, all of those things are contributing to increased sediment being released into the environment as well.
The second element, last week we learned that one of the major factors to sedimentation pollution is car tires.
Oh, there you go.
And that it was the major sediment across the world that was actually polluting the lower levels.
There you go. So is that actual like tiny bits of rubber that's coming off the tires itself? Yeah, and I'm sure it's also throwing stuff up, right, and making it loose and then allowing it to be able to run off as well would be another thing. Yeah, well, that doesn't, I guess it doesn't really surprise me that that's happening as well. But I mean, geologists are now, and archaeologists are now finding new geological formations that are basically polymers that are sticking together and creating this
weird new type of rock, so to speak, but it's basically polymers that are all, you know, sitting in under pressure and gluing themselves together and creating this weird new structure. So, you know, my archaeologist friends joke that, you know, we're going to go through and do the whole digs. And it's like, oh, okay, well, here was the Stone Age, here was the Bronze Age, and oh, here's the Plastic Age, right? Like we know exactly what they were doing. The food's still there. Yeah. Oh, and then got another question online. Cucumbers in Hervey Bay. I conject that sea cucumbers are important in terms of bearing and processing particles, but not for, yes, definitely there is sea cucumbers in Hervey Bay. And they are bioengineers. They're ones that are, they take in sediment and actually grind it down into smaller particles, particularly important in coral reef environments. But yes, they definitely do that. I don't think they're cleaning up the plastic though. So you need a lot of them.
Well, a small question from my end. You showed the stats around, you've seen decreases in total amounts of rubbish,
Yeah,
but still a similar level of plastic bags and bottles.
yeah.
Any particular theories as to what's causing that persistence? Is there a half-life to these things in the environment, or is it purely they're still getting out there?
I think it's a two-edged sword to answer that question. First of all, I think with the plastic bags in particular, there's not as, you don't see them visually as frequently as you do things like a plastic bottle or something, which they're heavier, they don't tend to blow around as much. So I think that's one side of that component, because you weren't necessarily catching them a lot in the early surveys anyway. We're still kind of seeing the same lowish levels that we had seen previously. But then as far as the bottles are concerned, we've actually definitely seen a reduction in the plastic bottles. And that's as soon as the container deposit scheme came in. They're worth money. So people started collecting them, right? And so they're being removed, or they're holding on to them to be able to recycle them. Although the novelty of that, I don't know how long that's still lasting. I don't know. I know when it first came out, there was a lot of people doing that, but I don't know if it's still continuing. Yeah, that's the thing. Yeah.
Well, we might wrap it there. Thank you again, Kathy. Fantastic. And very
Thank you.